SoC Blockset support package adds new capabilities to the multi-core modeling such as CLA and ARM Cortex and support. You can use these accelerator and heterogeneous core modeling capabilities for your real-time control solutions. You can simulate the model and generate code for the TI F28379D and TI F283ATXT microcontrollers with this support package. In this figure, the bottom picture has been taken from the TI datasheet. As we all know, we have 5 computing units in TI F283ATX microcontrollers to model. Let's take this as an example. As you can see, SoC blocks in the SoC blocks semantics, the computing unit is a combination of task manager and model reference. With this combination, we can model CPUs as well as CLA for simulation and code generation. For data exchange between the computing unit, we can take advantage of inter-process data channel block to exchange data periodically or asynchronously between the cores. In the next slide, I will show how you can select the computing unit for simulation as well as for the code generation. The processing unit selection is available in the hardware setting tab of the model configuration. In the hardware implementation tab of the reference model, you can select the processing unit for code generation. In SoC Blockset semantics, the top model do not take part in the code generation. So the processing unit of the top model will always be selected as none. For CLA processing unit, you must use CLA Task Manager block along with the reference model. It is a customized version of the existing Task Manager block, as it can schedule maximum number of 8 tasks, and these tasks do not have real priorities, and it doesn't support preemption during the simulation and code generation. Please note these limitations are basically coming from the underlying target which we support currently. For event mapping, you can use the task mapping app, which lists all the associated events for the selected processing unit. The sources can be mapped against the task names provided in the task manager configuration. This is how one can configure the model for simulation as well as for the code generation. Now let's look at some use cases. This use case is for CLA. In this example, CLA and CPU have been modeled to work as an independent unit. The first task manager is scheduling the CPU task, and the CLA task manager is being used to schedule the task for the CLA processing unit. In the second use case, CPU is triggering the CLA task asynchronously. You can see event line connecting CPU1 reference model and CLA task manager block. In this, triggering is possible by using software trigger block inside the CPU1 reference model, which generates the event to trigger the CLA task manager block. Let's discuss more about the software trigger block. By using the software trigger block, you can configure task numbers between 1 to 8, trigger condition like rising edge, and trigger type. Coming to the third use case, which demonstrates how we can exchange the data between the CPU and CLA. As you can see in the model reference block, these model reference blocks are connected through the IPC channel block, which provides channel for the asynchronous data transfer between the two cores. The IPC block manages the data exchanges across the homogeneous and heterogeneous core asynchronously. You can also model the communication buffering delays using the IPC data read, IPC data write blocks, and you can visualize the diagnostic information like number of buffers used and number of buffer overrides. The data exchange between the CPU and CLA uses the code mapping feature from the embedded coder. With this support package, this mapping will be done automatically. So in summary, you can model the heterogeneous code with Task Manager for simulation and code generation. While generating code, you don't need to worry about the core synchronization and model synchronization. IPC data channel helps you to exchange data asynchronously between the cores. Last but not the least, you can now simulate the non-primitive tasks with the CLA, which helps in simulating the CLA tasks and with the help of this CLA Task Manager block. Thank you for your attention.